our today's topic as alkynes. As we all know, alkynes, they are acyclic, unsaturated hydrocarbons, which contain carbon-carbon triple bond. And as we know, their general formula is what? CnH2n minus 2. Clear? N की नंबर, N का जो नंबर है वो यहाँ पे 2, 3, 4 कुछ भी हो सकता है. And since we have studied the structure of triple bond, the first member of alkyne series is ethyne. We all know that their common name is acetylenes. So the first member is ethyne, and not going into the details, we all know about it, about their structure. जैसा हम इसके बारे में जानते हैं कि इसमें अगर आप देखेंगे तो sp hybridization होता है. That means this is a sigma bond. It undergoes sp hybridization. As you all know it very well. जहाँ पे भी इसमें hybridization हमने देखा है तो what it undergoes? It undergoes sp hybridization with one hydrogen atom. So that is why this becomes C triple bond. अगर ethyne को देखें तो what you have is C2H2. And if you see, the bond length is 120 picometer. This bond length is 120 picometer, and this CH bond length is 107.9 picometer. As you all know it very well. लेकिन in spite of, as you can see here, इनमें अगर आप देखेंगे 2 pi bonds हैं and 1 sigma bond. In spite of these two, alkynes, they are very less reactive in nature. What alkynes are? They are less reactive. मतलब alkenes के comparison में देखा जाए तो alkynes, they are very less reactive in nature towards the additional reactions. Clear? And alkynes, जैसे alkenes, geometrical isomerism show करते हैं, है ना? But alkynes, they do not show geometrical isomerism. उसके पीछे जो reason है वो क्या है? They have a linear structure. Now we will move on to the nomenclature of alkynes. थोड़ा सा alkynes के nomenclature में देखते हैं. Common system में alkynes, they are named as derivatives of acetylene. The alkynes, they are named as derivative of acetylene, but in IUPAC system they are commonly called as alkynes. Clear? And you know it very well. इसमें थोड़ा सा एक value based कुछ points देखेंगे. Let us see. If you have value of n, the value of n is 2. What is the value of n? The value of n is 2. So their general formula is what? C2H2 or CH triple bond CH. And their common name is, as I told you, acetylene, and their IUPAC name is ethyne. In the same way, when you have the number, 3, when you have the value of n goes as 3, so what it becomes? Obviously C3H6. When the number of n becomes 4, so what it becomes? It becomes C3H6, or you will find C4H8, and you have C4H8. मतलब but 1 and but 2 or like that way. Clear? 1 and but 2 So C3H6 is what? What is this C3H6? Propyne. C4H8. जैसा मैंने बताया था, it can be but 1 and it can be but 2 and this is what you call as propyne. Now थोड़ा सा और हम लोग अब इसके बारे में कुछ और डिटेल में देखेंगे. What you have is 1, 2, 3 and 4. And what is the question? 3-methyl but 1 ine, that means the triple bond lies over these positions. So let it be 1, 2, 3, 4 CH. Clear? And then after 3-methyl but 1 ine, that means what? CH3. So this becomes 3-methyl but 1 ine. In the same way, we will now talk about the isomerism in alkynes. Isomerism in alkynes. If we talk about the isomerism in alkynes they show four type of isomerism. The first isomerism is position isomerism. See, position isomerism is shown by the first two members, that is ethyne and propyne. तो चलिए देखते हैं one form only, the first two members they exist in one form only. तो actually position isomerism चालू होगा कहाँ से? It will start from butene. Clear? So let us see but 1-ine and but 2-ine. How will you do it? Clear? And CH3. So this is but 1-ine and this is but 2-ine. They differ only in what? Position number. What they differ in? यहाँ position कहाँ है? CH और C के बीच में. 1, 2, 3, 4. And here 1, 2, 3 and 4. So 2 and 3 and this is 1 and 2. Clear? So that is why this is but 1-ine and this is but 2-ine. In the same way, we have chain isomerism. What do we have is, we have the chain. This was the position isomerism. Now we will talk about the chain isomerism. Alkynes having 5 or more carbon atom, they show chain isomerism. क्यों ऐसा करते हैं? Because of the difference in the structure of their carbon chains. Clear? Right? तो let us see, बना के देखते हैं pent 1-ine. Pent 1-ine, CH3, CH2, then CH2, C triple bond, CH. 1, 2, 3, 4, 5. This is pent 1-ine. What it is? Pent 1-ine. In the same way, we have 3-methyl buta 1-ine. How can you do it? CH3, CH, then again CH3, then C triple bond, CH. So this is what 3-methyl buta 1-ine. Same molecular formula but different structures. One is the straight chain, another one is the branch chain. So this one is the chain isomerism. In the same way, alkynes they also show functional isomerism. When I am saying functional isomerism, that means what? देखिए, actually alkynes हैं क्या? Alkynes are the functional isomers of dienes. And we all know what is diene? What is diene? अरे diene क्या है? Such compounds which contains 2 double bonds. If any organic compound contains 2 double bonds, then it is diene. And if any organic compounds contains 2 triple bond, that is diene. Clear? So, और जैसे मैंने आपको बताया कि alkynes they are functional isomers of dienes. For example, let us see to that. How and in what way? You have but 1-ine. If you can see, you have but 1-ine. As you can see here in this structure. And you have but 1,3-diene. And how will you narrate but 1,3-diene? CH2 double bond, CH single bond, CH double bond, CH2. So this is what? This is buta 1,3-diene. So this proves that alkynes they are functional isomers of diene only. Clear? It can be buta 1,3-diene and it can be buta 1,2-diene also. That can also happen. And the fourth type of isomerism shown by alkynes, as I told you, alkynes they show 4 type of isomerism. The fourth type of isomerism, as shown by alkynes, they are commonly known as ring chain isomers. What they are known as? Ring chain isomers. Alkynes, they show ring chain isomerism with cycloalkenes. In what way? Suppose I do like this propyne. Am I right? This is propyne. And it can be also made as cyclostructure, the cyclic structure. How? Cyclopropene. They both are ring chain isomers of each other. Chaliye, thank you. That's all for this classification.